Step 5.2 Distance-based methods. Next, we want to look at back clustering as a clustering method to obtain results, and we'll show that using the winter activity dataset, which is available in package MSA. So for loading the data, you need to have the package installed, but then this can be loaded like that, and we look at which variables are contained in the dataset using call names. So we see we have 27 binary variables in that dataset available, and we want to cluster this now using backed clustering. Backed clustering is implemented in package FlexClust. We have already used the package before in that step, so it's already loaded. We don't need to reload it, but because it's backed clustering uses a combination of k-means clustering and hierarchical clustering. Again, we need to set a random seed to ensure reproducibility of results. The function which does back clustering is function bclust, where we have as input the dataset we want to cluster. And as you remember, we have two different steps. First, the base step, where k-means clustering is performed for different bootstrap datasets. So we need to specify how often do we want to run that base algorithm on how many datasets. So that's what base.iter does. So here this means we are drawing 50 datasets and we are running k-means clustering on that using that's a partitioning algorithm, so we are fixing the number of clusters we're looking at, and that's base.k equals 10. So the algorithm will run k-means clustering on 50 bootstrap datasets with k equals 10, and will return that solution, which gives us 500 centroids. And these centroids will then be clustered using hierarchical clustering, and the object will be returned. Does the bclust. We can see the progress of the fitting function because we have the committee members. This plots for each run of the base algorithm that it is running now. So this will go from 1 to 50. And once the base algorithm has run, the centroids are extracted, and those are clustered using hierarchical clustering. And we'll see that is also done. And the output, we can look at the default plot function for objects returned, which gives us the dendrogram and some additional information on what would be a reasonable point at cutting the dendrogram. So this is the dendrogram, and here the information is given how high is when we merge the last 2 points, what was the height when the second and third were, and so on and so forth. So this is the height rescaled to 0, 1. When the last 2 groups were merged to 1, that's the height when this group 2 and 3 were merged to 1, and so on and so forth. And the differences in heights are plotted here. So they can be an indication of what would be a good point for splitting. We see here we have high values, and starting from 5 there are low values. So this would indicate to cut the dendrogram at 4 clusters. However, if you inspect the 4 cluster solution, you'll see that 1 cluster is really big, and it would make sense to split it further to get more equally balanced clusters in the sense of the number of respondents. So we'll separate at 5 clusters, and we can do this using, for example, the bar chart function. We can put in our object returned, and we say we want to cut the hierarchical clustering for 5 clusters, which will result in a 5 cluster solution finally, where we can also assign respondents now to its 5 clusters and calculate centroids for these clusters. And the bar chart will give us the profile plot for these centroids. So this is the final clustering we have. We see how many respondents are in each of the clusters, and we see the profiles. The bars indicate the relative proportion of agreement in that segment, and the red dots are the overall agreement over all observations. So this is the same as we would have gotten for partitioning clustering. Every cluster we have contains a certain number of centroids, and we can also assess the variability of the centroids, and this is available using the function pvplot. Makes a box plot of that object for the 5 cluster solution, and we only want to see the variability of the centroids assigned to cluster 5. So here you could either put in a vector to get the results for all the clusters you're specifying, or pick a specific cluster. We are looking at the variability of cluster 5. So we see to cluster 5, 133 centers were assigned in our hierarchical procedure. So we see that it was very clear that all of the clusters had, all of the centroids had high values for alpine skiing,